Hi everyone, in this video we are going to learn which index we should use according to our use cases. So let's see it. So first of all we have normal use case. Let's say if we have a very generalized use case, let's say we have a student table, we need to index on our ages, we need to index on our names, something like that. We need to run some basic range queries. You can simply go with B trees and B plus trees. It's going to solve most of your problems. So B trees are going to take read of O login time and the write will take O of login time. It is very good for read heavy system, but let's say you have a very write heavy system. In that case, you have to change your indexing technique. We will see that which indexing technique you can use in that case. Now we have covered that our normal use case. We can simply go with B trees and B plus trees. Okay. And like if someone asks in the interview, you can simply say that. Now let's say when we can use our hash indexing, we use our hash indexing in the case of email or username searching. Let's say that there is a select query select star from student where name is equals to Savage. So this particular name column is going to be a text field, or you can say a varchar field. In that case, you can go for our hash indexing. Hash indexing works very well with our text data because B trees and B plus tree are going to sort the data in sorting. It means that when there is going to be a string, it's going to sort the data in lexicographical order. So whenever they are going to be searching, it is going to take O of login time for a string as well. But when you are going to go with hash indexing, it will take O of 1 time in read, and write is also very fast. Write is also amazing, read is also amazing. Only problem with hash indexing is that it is going to store the data into RAM or in memory. So it means that it is going to be very costly. So if you are going to use an hash index, it's going to give you very excellent speed, excellent read speed, excellent write speed, but it's going to be very costly. This was the first problem with hash index. Second problem with hash index was related to range queries. Okay, it works very well when there is something really specific, like say if searching Savage, you are searching any keyword, it will give you a very fast result. But whenever you are going to go for, let's say, a range query, it is going to work very slow. I think you have understand this point as well. Now let's move to the third one. When to use inverted index? Inverted index, we can use it for fuzzy searching or Google crawlers. And I also mention one query here, select star from student, where name is like %abc%. It means that, let's say if I have to search the names in our student table where name, let's say the middle name is going to be, let's say, Sharma. In that case, we can go and use our inverted index. Of course, we can use B trees and B plus trees here as well, but I already told you about the lexicographical problem that they are going to store the data in the searching will be not that efficient. So what we are going to do in that case, we are going to store the key here in the inverted indexes. Let's say we are going to store the word Sharma, and in front of that we will key, let's say it will be in row number 1 and row number 2. Usually this inverted index is used in Elasticsearch and Google search engine as well. Let's say there is a browser, in that someone type Donald Trump. So in our documents mean in our HTML file, or you can say links, there will be, let's say, Donald, and in front of that there will be something like that. It will present in this link, comma, and this link. So whenever you type Donald in our search engine, when we will press on the search button, it will find in our inverted index table and it will figure it out in which documents this Donald word is present. Something like this, our inverted index is going to work. And it's very good when you are going to make something like a Google browser, or let's say if you are going to make a functionality like searching. So now let's move to the fourth point, that is bitmap indexing. And we use bitmap indexing when we have cardinality columns. Cardinality columns means like something like enums in Java. You can understand it like, let's say, gender, that can be male or female, marital status, married, divorced, single. So in that case, bitmap indexing is going to make a table of indexing table, something like this, that it will make all the columns, all the enum as the columns, married, divorced, and single. And whenever the row is going to be married, so it will pass 1 in it, and all the other rows are going to be 0. Let's say the other row is going to contain to be a single, so it will be something like this, 1, 0, and 0. So this is how our indexing table is going to look in the case of bitmap indexing. Now we use bitmap indexing when there are so much AND or queries. Let's say there is a table that contains the column of gender and marital status, and you need a data something like that a person is a male and married. In that case, there are going to be two bitmap indexing table, married, divorced, and single, and there is going to be one more table something like this, male and female. So it's going to be an easy operation to connect these two tables and merge them instead of running a complete query and do some indexing with the help of B trees and B plus trees. B trees and B plus trees operation is going to be little high in the case of this thing. We can simply go with bitmap indexing in the case of cardinality columns. I think I'm able to understand you this. So bitmap indexing was first launched by the Oracle. This is, I think, all about bitmap indexing. Now let's understand the fifth use case. Now let's talk about the fifth use case, that is going to be of our LSM trees. So LSM trees is used by Cassandra and RocksDB. It was made in such a way that read is still going to be of O of log n. How we are maintaining the read, we have studied about it, that read is going to be is again log O of n with the help of Bloom filters, and we were doing some binary searching, and there is going to be B tree concept as well. We studied this thing in our LSM tree video. And secondly, write is going to be comparatively fast because of write ahead logging that we were maintaining for durability, and we were going to store the data in our mem tables, and we are maintaining SS tables. We have studied about it as well. In our LSM tree video, you can just go there and watch it out how we store the data in LSM trees. So this is about LSM tree, and it's going to be used when we have a write heavy system. Read is going to be still same. So let's say we have a write heavy system, we'll go for LSM trees instead of B trees and B plus trees. Now the sixth point is related to geospatial indexing. So geospatial indexing, I made a separate video for it, that whenever there is a data related to in a plane, it means whenever you have a data related to latitude or longitude, whenever you have coordinates, in that case, you have to use geospatial indexing. So I divided this geospatial indexing in two ways, that either the data can be static or dynamic. Static data means that the data related to restaurants, either the data is not changing so much. Okay, this is not a write heavy system. It's a very simply, we are just stored the data and now we are using it. In that case, we can simply use geohashing. I'm just going to tell you, if a static data, you can go with geohashing. Whenever there is a dynamic data, something like Uber drivers are changing their location continuously, Zomato orders, something like that. In that case, you can use QuadTrees and R-trees. So in QuadTrees and R-trees, we studied about density. So let's say in Bangalore, there are a lot of Uber drivers, and let's say in a small town like Mathura, there are very less Uber drivers. So this QuadTrees and R-trees are of course going to be a square box that are going to maintain a square boxes inside them, like there are going to be some coordinates. But whenever there is going to be high density area, they are going to make small boxes, and whenever there is going to be less density area, we are going to make a big large box. Something like that. I covered this thing in geospatial indexing video. You can just go and understand the complete concept there. This is all about the general use cases and the answers that you can give to your interviewer if someone directly asks you about indexing, and the detail I cover in my playlist. I hope you enjoyed this video as well. Thank you for watching me, and let's meet in some other video. Thank you for watching me, and bye bye.